Hello everyone, and welcome back to the video lecture series on graphing linear equations. Today we are going to start the process of graphing linear equations. We're not going to draw too many graphs today because we do need to focus on a concept called slope, and you need to gather an understanding of what slope is before we can really start graphing. So what we are going to be graphing are what are called linear equations in two variables. So the graph of a linear equation in two variables is the graph of all the ordered pair solutions to the equations. In the last video, I showed you guys how to test to see if a point was a solution to a two-variable equation. Now, two-variable equations have an infinite number of points that are solutions, so the graph is going to be the collection of all of them. So a linear equation is an equation who has no exponents higher than 1. So we're not going to be seeing anything like, x squared or x cubed right now. All of the exponents are going to be 1. These are what is known as the equation of a line, because when you graph a linear equation, it is going to form a straight line. Now, a straight line in this class means a line that doesn't bend, so this, a line that doesn't curve. This is a curve. This is a line, even if it's slanted and it's a straight line. So every point on that line is a solution to the equation. So any ordered pair on that line, if you plugged it into x and y in the equation, would satisfy the equation. Any points that are not on the line are not solutions to the equation. So one way to graph an equation is to make an XY table. This is probably the slowest method of graphing, and we're not really going to be using this all that much. I am going to show you shortcuts and faster ways to graph these linear equations. However, if you completely forget the shortcuts and you have no idea what to do, this is a good method to fall back on. It takes forever, and it's not the best, but in a pinch, it will help you generate some sort of graph. So graphing using a table of values involves you choosing values for x, and one at a time plugging them into x in your two-variable equation to get the corresponding y coordinate. So again, this is going to take a long time. There are easier shortcuts. However, if you forget them, you can always fall back using this. So oftentimes, it is easier to graph a line when y is by itself, and we're going to get in the habit of always getting y by itself in these equations if y is not already by itself. So just get in the habit, solve the equation for y first. Then we're going to choose 3 values for x and make a table of values. You should choose 0 because you really should know what's going on at 0, and you should choose at least one positive number and one negative number. Then you're going to plug those into x in your equation one at a time to get the corresponding y coordinate. Then you're going to plot these points as ordered pairs and draw a line between them. So we're going to take this equation, and the first thing I'm going to do is I notice that y is not by itself, so I'm just going to quickly get y by itself first just to make my life easier. So since y is being added to 2x, I'm going to get rid of this adding 2x by subtracting 2x from both sides. So y is now by itself, and yes, you can write it as 3 minus 2x. I am going to get you in the habit, though, of writing the x term first, so I'm going to put the negative 2x first. And since this 3 is positive, I'm going to separate them with a plus 3. You'll see why in the next video. So then I'm going to choose 3 values for x, one negative number, 0, and one positive number, and one at a time I'm going to plug them into this equation in for x to get their corresponding y coordinate, and this space right here in the middle is just to show the work. So I have y equals negative 2 times negative 1 plus 3. Negative 2 times negative 1 is positive 2. 2 plus 3 gives us 5. So the y coordinate that goes with this is 5. So I'm going to plot this as the ordered pair negative 1, comma 5. Negative 1, comma 5 is about right there. Then I'm going to do the same thing with 0. So I have y equals negative 2 times 0 plus 3. Negative 2 times 0 gives us 0. 0 plus 3 gives us 3. So 0, comma 3 is going to be the next point that I plot. So 0, comma 3 is right there. Then I'm going to plug in 1, so I have y equals negative 2 times 1 plus 3. Negative 2 times 1 is negative 2. Negative 2 plus 3 is positive 1. So 1, comma 1 is going to be the next point I will plot. Now with these 3 points, we have a pretty good sense of what the line is going to look like, so I'm going to draw a line between them. Now it is important that you put arrows on both of these, because I just picked 3 generic x values. Technically, this line goes on forever and ever in both directions. So since this is only a piece of the line and it does technically go on forever and ever, you do need arrows on both ends. Now that was obviously extremely slow, and for more complicated lines that would be a lot of work. So before we get into what the shortcuts are for graphing, we need to talk about this concept called slope. So every single line has a slope, and a slope is can be thought of as a measure of steepness, and slope is also known as a rate of change. It is measuring how fast are the y-coordinates changing as the x-coordinates change. So examining the slope of a line, if the line stands for something in a real-life context, can tell us if the quantity being modeled is either increasing or decreasing. And much like a ski slope, the steeper the slope, the faster the rate of change. So slope can also be thought of as rise over run, meaning that slope is always some sort of fraction. We are never going to want to write slope as a decimal. Slope should always be expressed as a fraction. And it is the fraction, the amount of rise, over the amount of run. Well, which variables rise? The y's are going to be the variable that rise. So y's rise. So there is a formula for slope, which you do need to memorize. So you do need to know this formula for slope. I am not going to give it to you on any sort of exam. So the slope formula is the rise divided by the run. The amount of rise, since y's rise, you can think of the rise as the change in the y-coordinates. So how much the y-coordinates change. And the run, the variable that moves left to right, is x, so the run is the change in x. So the change in the y-coordinates is the difference between the two y-coordinates. So what I have here are 2 different points. Each of these points have an x-coordinate and a y-coordinate respectively. So since these are going to have different x and y coordinates, and I want to keep these variables somewhat generic, I am going to differentiate between them with what are called subscripts. So this first point here, the x-coordinate of the first point is called x1. The y-coordinate of this first point is called y1. And just so that you can tell them apart, the x-coordinate of the second point is x2. And the the y-coordinate of the second point is y2. So the variable that is most often used for slope is m. Don't ask why. The change in the y-coordinates is going to be the difference in the y-coordinates, how much the y-coordinates change between the first point and the second point. Well, the change in the y-coordinates can be thought of as the difference between the y-coordinates. So that is going to be the second y-coordinate, y2, minus the first y-coordinate, y1. And then divided by the run can be thought of as the change in x's. How much did the x-coordinates change from the first point to the second point? So the run is going to be the difference between the x-coordinates. So the run is going to be the second x-coordinate, x2, minus the first x-coordinate, x1. And then that is the slope formula, and you do need to know it. So what we can do is we can actually use the slope formula to find the slope between 2 points. So we have the points 2, 1 and 4, 2. And what we're going to do is we are going to find the slope of the line that passes through the 2 points. You might remember from high school geometry that any 2 points will determine a line. So these 2 points, there will be some sort of line that connects them, and we're going to find the slope. So the slope formula is going to be m equals the difference in the y-coordinates, y2 minus y1 over x2 minus x1. So 2, 1 was the first point listed. The x-coordinate is 2 and the y-coordinate is 1. So I'm going to call the x-coordinate of the first point listed x1. So 2 is going to play the role of x1. I'm going to call the y-coordinate of that first point y1. So 1 is playing the role of y1. Then I'm going to call the x-coordinate of the second point x2, so 4 is x2. And I'm going to call the y-coordinate of the second point y2, so 2 is y2. So what I'm going to do is I'm just going to plug each of these values into their appropriate spots in the slope formula. So m equals y2, which I have labeled as 2. This minus sign is part of the formula regardless of what y1 is. So minus y1, which is 1, divided by x2, which I have labeled as 4, minus x1, which I have labeled as 2. Now you might remember when we did order of operations that whenever you have addition or subtraction inside of a fraction like this, you do need to do the subtraction first before the division. And remember, leave your slope as a fraction. So 2 minus 1 is 1 over 4 minus 2 is 2. We are not going to write this as 0.5. We are going to leave our slope as a fraction. So the slope of this line is 1/2. So if you were to plot these 2 points, 2, 1, and 4, 2, this line that connects them would have a slope of 1/2. So what we're going to do for this next one is the same thing. We're going to find the slope of the line that connects these 2 points. So here is the slope formula. So slope m equals y2 minus y1 over x2 minus x1. So this first point that is listed, I'm going to call the x-coordinate of this first point listed x1. The y-coordinate of this first point listed is going to be y1. Then I'm going to call the x-coordinate of the second point x2, and the y-coordinate of the second point is going to be y2. So then I'm just going to plug each of these into their appropriate spots in the slope formula. So slope is going to be y2, which is -2. Now keep in mind, these minus signs right here are part of the formula, and they're always going to be there regardless of what y1 and x1 are. So -2 minus y1, which I've labeled as 1. Then divided by x2, which I have labeled as 2. This minus sign is part of the formula. However, x1 is -3, so we do have a double negative. Be very careful of those. So then I'm going to do this subtraction first. So -2 minus 1 is going to give us -3. Over, the double negative will turn into addition. 2 plus 3 is 5. And you're just going to want to leave it as a simplified fraction. So -3/5 is your slope. Then what we're going to do is we're going to plot each of these points on this coordinate grid. So we have -3, 1, and 2, -2. And the line that connects them, this line has a slope of -3/5. Now, remember from the last video that you always read a graph from left to right, just like you read the English language. So if you trace a graph from left to right, if the line slants upward, it is called increasing, and its slope is going to be positive. If when you trace your line from left to right, it slopes downward, it is called decreasing, and the slope is a negative number. So you can easily tell if a line has a positive or a negative slope just by tracing it from left to right with your finger. If your finger is moving up as you trace from left to right, that means the slope is positive and the line is increasing. If you trace it with your finger and your finger is moving down, the slope is negative and the line is decreasing. So what increasing means is that as the x values get larger, the y values are also getting larger. So the y coordinates are going up as x goes up. Decreasing means that the y values are getting smaller as the x values get larger. So as x keeps going, the y values are getting smaller and smaller. Now, example 1 over here, if you were to trace this graph from left to right, you will notice that it is slanting upward. So this line has a positive slope, which we can see from this being a positive number. If we were to trace this graph from left to right, you notice that we are slanting downward, so this has a negative slope, which you can see by the slope being a negative number. So example 1 was a positive slope, example 2 was a negative slope. Now there are other types of slopes, and we're going to investigate one of them. So we're going to find the slope of the line that passes through the points 7, 5 and negative 1, 5 first. Then we're going to plot these points and sketch the line. So I'm going to call the x-coordinate of this first point x1. I'm going to call the y-coordinate of this first point y1. I'm going to call the x-coordinate of the second point x2 and the y-coordinate of the second point y2. So then I have my slope formula, m equals y2 minus y1 over x2 minus x1. And I'm going to plug in each of these values into their appropriate spots in the slope formula, remembering that these two minus signs are part of the formula and need to stay there. So y2, which I have labeled as 5, minus y1, which I have labeled as 5, divided by x2, which is labeled as negative 1, minus x1, which I have labeled as 7. So 5 minus 5 is 0. Negative 1 minus 7 is negative 8. 0 divided by negative 8 is 0. So your slope comes out to 0. So let's actually graph these 2 points and see what the line looks like and why the line has a slope of 0. So if you graph 7, 5, 7, 5 is right there. And if you were to graph negative 1, 5, it is right there. And I'm going to connect these points the best I can. That was pretty good. And if you notice, this line is completely flat. So this line does not slant up or down as you trace it from left to right. As you traced it from left to right, as you just saw, it just went straight across. It didn't slant up and it didn't slant down. That is what is called a horizontal line. Horizontal lines have a slope of 0 because the y-coordinates are neither increasing nor decreasing as we go across. Notice how the y-coordinates for each of these 2 points were exactly the same, and that is why the slope came out to 0. So for horizontal lines, all of the points have the same y-coordinate, so the y's are not changing as the x runs from left to right. Now we're going to take these 2 points, which we have graphed already, and we're going to find the slope between them. So slope m is equal to y2 minus y1 over x2 minus x1. So I'm going to call this first point here x1 and y1. And I'm going to call this second point here x2 and y2. So then I'm just going to plug each of these into their appropriate spots in the slope formula. So y2, which I've labeled as negative 2, minus y1, which I've labeled as 1, divided by x2, which is 3, minus x1, which is also 3. So negative 2 minus 1 is negative 3, over 3 minus 3 is 0. And you cannot divide by 0. A 0 on the top of a fraction makes the whole fraction equal to 0. However, you cannot divide by 0. So when you have a 0 in the denominator like this isn't actually a real number. So what we say is that this is what is called undefined, meaning this isn't an actual number. You can't divide by 0. We've just run into something that's mathematically impossible. So what we say is that the slope is undefined because you cannot divide by 0. Now, if you take a look at this line, this is obviously a vertical line. So vertical lines have an undefined slope. The slope of a vertical line is undefined because if you do the slope formula, you get a 0 in the denominator. The reason why is the 2 points that made the vertical line had the same x-coordinate. So every single point on this vertical line is all going to have the same x-coordinate, positive 3. And the x-coordinates being the same are why we got that 0 in the denominator. So with vertical lines, the 2 points will have the same x-coordinate. So this is just kind of a summary of everything that we have done with slope so far. Remember, Graphs are always read from left to right. So if you trace a graph from left to right and the line slants upward, like in this first example, this has a positive slope. If from left to right the line slopes downward, you have a negative slope. If the y-coordinates do not change and they just remain flat like this, you have a slope of 0 and the line is horizontal. So horizontal lines will have a slope of 0. And if you have a vertical line, the slope is undefined. So that is where we are going to leave this for now. We're going to pick up in the next video with actually using slope and using slope as rise over run to draw the graphs of lines. So stay tuned for that. We're going to be picking up with more slope and actually tying it all together and graphing our first lines. So thank you all very much for watching, and I will see you all in the next video. Bye-bye.